Hello, my name is Aisyah B. Fadli. I will explain the introduction about laboratory hazard identification, risk assessment and control, or HIRADC, for and Sludge Settleability research using jar test and SVI at President University Environmental Chemistry Laboratory. Jar test and sludge volume index, or SVI, measurements are essential in water and wastewater treatment process, but come with various risks. Jar tests determine optimal coagulant and flocculant dosage, including chemicals like Ph.D. and NaOH, which pose risks such as skin irritation, spills, and equipment-related injuries. SVA evaluates sludge settling ability with risks including exposure to pollutants, odor, and repetitive work injuries. Adopting HSE protocols like PPA, proper ventilation, and waste management ensure safety. Effective risk management such as HIRADC or hazard identification, risk assessment, and control is crucial for maintaining occupational health and safety. This approach involves identifying hazard, assessing risk, implementing controls, and monitoring effectiveness. By addressing risks like chemical exposure, biological contamination, and operational challenge. Example, electricity issue. Laboratories can foster a safer environment. This study emphasized the importance of proactive risk management to create a safe and efficient laboratory environment for jar tests and SVI at President University. It highlights the need for robust safety practice, compliance with OHS standards, and proper waste disposal. The findings provide a framework for enhancing laboratory safety, benefiting both learning and research.
My name is Aisyah B. Siswohartono, and for the next is I want to explain about the methodology. The first one is start. The first stage involves selecting the discussion topic, outlining the framework, and identifying the observation site. This analysis was conducted in the Environmental Chemistry Laboratory, President University. The second is identification of HIRADC objective. The stage sets the safety objective for the jar test and SVI experiments, focusing on chemical handling, equipment use, and operation standards like ISO 4500 were referenced to ensure best practice. The third is determination of observation parameters. This stage identifies hazard and risk in the jar test and SVI process, based on laboratory observations and tool usage for water treatment analysis. The fourth is risk assessment, hazard identification, and prioritization. This stage of the HIRADC analysis focuses on identifying potential hazard at every step of the jar test and SVI experiments, including preparation, operation, and cleanup. The fifth is implementation of control measures. This stage focus on implementing control measures to reduce risk during experiments. These measures follow the hierarchy of controls, such as eliminating hazard, using safer alternative engineering controls like protective ventilation, and administrative controls like PPE, gloves, masks, Google, and lab coats. The sixth is implementation and supervision. During the jar test and SVI experiments, control measures were implemented under the supervision of laboratory assistants and lecturers. Compliance with safety protocols was ensured at all times. The seventh is evaluation and monitoring. Post-experiments, the control measures were evaluated to determine their effectiveness. Monitoring activities include regular inspections of equipment and periodic reviews of procedures. And the last is reporting. All HIRADC findings and implementations were documented in comprehensive report submitted to the supervising lecturer. The report includes hazard assessment, control strategies, and recommendation for future improvement. So, for the next is case study, risk management on jar test and SVI experiment. Jar test and SVI or sludge volume index experiment background. The first one is jar testing is a fundamental laboratory procedure employed in water and wastewater treatment to evaluate the effectiveness of coagulants and flocculants. The primary goal is to determine the optimal chemical dosage required to achieve desired water quality parameters, such as turbidity and color removal. This process is critical for facilities that need to comply with environmental regulations regarding effluent quality. So for the next is background of SVI or sludge volume index. The sludge volume index or SVI is an important measurement that assesses the settleability of sludge produced during the treatment process. A high SVI indicates poor settleability, which can lead to operational challenges such as increased sludge volume and potential violations of discharge limits. Therefore, conducting jar tests alongside SVI assessment provides a comprehensive understanding of the treatment process efficiency.
Hello, my name is Aulia R Rafiqi, and the next slide I will be explain about objective of jar test and SPI experiments. 1. Optimize chemical usage. 2. Improve water quality. 3. Monitor sludge settling. 4. Enhance process understanding. And then next, common challenge in jar testing and SPI assessment. 1. Sampling error. 2. Instrument calibration. 3. Environmental factor. 4. Operator variability. And 5. Time constraint. And next, risk minimization strategy. 1. Contamination prevention. 1. Use sterilization equipment. 2. Follow standard operation procedure or SOPs. And 2. Data integrity assurance. 1. Quality control measure. And 2. Regular calibration. 3. Safety protocols. 1. Personal protective equipment or PPE. 2. Training programs. 4. Environmental monitoring. 1. Control environmental condition. And 2. Document condition. And 5. Standardization of producer. 1. Develop standardization protocols. And 2. Operator training. And next, method HIRADC. Step to implement HIRADC. 1. Hazard identification. Identify potential hazard affecting health, safety, and environment. 2. Risk assessment. Analyze the likelihood and consequences of identified hazard. 3. Risk control. Implement control measures using the hierarchy of control. elimination, substitution, engineering control, administrative control, and personal protective equipment or PPA. 4. Monitor and review, continuously evaluate the effectiveness of control measure. And the next slide, risk assessment for jar test and SPA experiment. The risk assessment for jar test and sludge volume index (SPI) experiment aims to ensure safety and compliance in the laboratory. It evaluates two main aspects: likelihood, which includes activity frequency, occurrence frequency, and export duration, and severity, which cover types of injuries, uh, illnesses, and financial impact. Likelihood is assessed from rare to frequent, while severity range from minor to catastrophic. Uh, Arithmetic integrate this aspect either qualitatively or quantitatively, enabling systematic risk identification and the implementation of appropriate appropriate control measures. This structured approach minimizes risk during experiment, ensuring both safety and operational efficiency.
Hi everyone, so my name is Jessica Malana and I will explain about the results of our paper or based on our title. So for the first one is the hazard identification. The first and most important phase in the HIRADC framework is identifying the hazards to avoid the mishaps and guarantee safety. And it entails the methodologically identifying possible cause of damage in the lab environment. And the research project of coagulation and sludge settleability research using jar test and SCVI is the following risks were noted and taken into account in detail, like chemical hazard. So exposure to dangerous chemicals that can result in burns, breathing problems, or skin irritation. Uh, for the chemical hazard, the source of the hazard is from making chemical solutions like fumes or spills, and direct touch when mixing or baking. And the control measures is put on PPE such as goggles and gloves. Make sure there is adequate ventilation such as a fume hood. Observe SOPs when handling the chemicals. And the second one is physical hazards. The physical hazard is slips and falls caused by chemical spills or injuries sustained when operating heavy machinery. And the source of hazard is from jars being dropped as a result of poor grip and it's slipping on a damp floors as a result of chemical spills. And the control measures is provide trace from for spills control, make use of sturdy lightweight jars, and employees should be trained in safe handling techniques. And the third is the operational hazards. So, misses or a malfunction of equipment might result in harm or mistakes in study. So, from the operational hazards, the source of hazard is the jar testing machines are not operating correctly, and then the inadequate calibration of measurement equipment, and then the control measures is like frequent calibration and upkeep, create SOP and over instructions, and then perform inspections on equipment before usage. The fourth is ergonomic hazards. So Physical strain brought on by extended standing or sitting are repetitive duties. So the sources of hazard is from the spending a lot of time watching jar testing and repeated manual labor such mixing or peering, and control measures is like over the ergonomic chairs or movable stools, plan frequent pauses, and implement the automation for routine tasks. And the last one is waste management hazards. So risk to the environment of or human health from inappropriate waste management. The sources of hazard is come from spills that happen by accident when waste is being transferred, and then the inadequate separation of hazardous and non-hazardous waste. And for control the measures, you can use the garbage containers with labels, educate employees on proper garbage disposal techniques, and then you can conduct routine audits of waste management procedures. So every laboratory hazard is different and needs a different set of controls. We can input in place focused interventions that protect the researcher's safety while preserving the integrity of experimental result by recognizing and classifying the risks into chemical, physical, operational, ergonomics, and waste management categories. Next slide is about the risk assessment for laboratory hazard. So the methodical process of assessing the possible risk connected to recognized hazard is known as risk assessment. This risk assessment is used to prioritize the control measures and estimate the likelihood and severity of each danger in laboratory studies involving the coagulation and sludge settleability utilizing jar tests and SVI. So in here we have three essential steps are usually involved in risk assessment. The first one is assessing the likelihood. So the likelihood that an incident will result from a hazard, and usually a scale is used to measure the likelihood, with 1 denoting rare and 5 denoting almost certain. And the second one is assessing the severity, the degree of potential injury or damage brought on by the hazard. And a scale is also used to rate the severity, with 1 denoting to finance and 5 denoting catastrophic. And the last one is how to determine your risk level. So to determine your risk level, the products of likelihood and severity. In here we have a formula: likelihood times by severity and equals to risk level. That's so risk level. It's the answer. Then you can determine thresholds. The risk level is divided into low, medium, and high categories. And in here you can see there are several risk assessment for laboratory hazard. For the chemical exposure, the value of likelihood is 4, severity is 3, risk level is 12, risk category is high, and the change of chemical burns or respiratory injury is moderate to severe. 3, and handling chemical regularly enhance the likelihood is 4. So and the next one is spillage during jar test. For the spillage during jar test, the likelihood is 3, severity values is 2, risk level is 6, and the risk category is medium. It's because handling liquids during the experiments increases the chance of spills, and then the likelihood is moderate and moderate 3, and the severity is low to moderate 2 because it could cause minor slips or injuries. And then the next one is equipment measures. The value of the likelihood is 3, the severity is 4, the risk level is 8. So we can get the risk category is medium. Since of appropriate training, the likelihood is modest. the likelihood is 2, but the severity is substantial, we get 4. And since improper use of the equipment could result in harm or inaccurate research. And then the last one is we have pastoral strain. The value of likelihood we have 3, and then severity 2, and the risk level is 6. So we can assume that it's medium. Given that researchers frequently operate in difficult situations, the likelihood is moderate. 3, as I said before, due to the relatively modest severity. Is 2, there may be minimal musculoskeletal problems or discomfort. Okay, and the next one is risk categories and actions. For the high risk of the risk level, it's until 10. So the high risk is 10 and needs to be addressed right away. The goal of controls should be to lessen the possibility and severity. For example, by implementing the engineering controls, strengthen procedures and improve the personal protective equipment. And for the medium risk, is needs prompt action like 5 until or less than 10, and it's concentrate on providing the modest engineering controls and reducing the exposure to administrative controls such as training and SOP. And the low risk is less than 5. So needs to regular attention. If the control in place are adequate, that risk can be tolerated, but they should still be checked on a regular basis. As you can see in here in the next slide, it's the diagram of risk levels of identified hazard. So the chemical exposure is the highest, and then the next one is equipment misuse and spillage during jar tests, and then postural strain. And next slide is you can see in here, this is the diagram, the pie diagram of distribution of hazard categories. So from this diagram, you can see in here, medium is 75% and the high is 25%. And you can see in here, and then for the control measures, you can see there are control measures for specific hazards in the lab. So control measures are tactics and steps used to reduce or eliminate risks related to hazard that have been recognized. The hierarchy of controls, which ranks the best risk reduction strategies first, serves as the foundation for the application of these measures. So the hierarchy of controls, which is arranged from most to least effective, covers and organized the method of risk management. In here we have several of the method. The first one is the elimination. So we can completely getting rid of the risk using non-toxic substitutes for dangerous substances in one example. And then the next method is substitution. We can use a severe substitute for a risky procedure, item, or piece of machinery. For instance, substituting less hazardous compounds for volatile ones. The third one is engineering controls. By separating workers from the risk by erecting physical obstacles or altering the workspace. For instance, using splash shields to prevent spills or fume hoods when handling the chemicals. And then the next one is administrative controls. So, by modifying rules, process, or work practices deliveries, for instance, putting standard operation procedures or SOPs into practice or offering the training. The last one, we have wearing safety clothing to lessen exposure to risk is known as personal protective equipment or PPE. For instance, donning the respirators, lab coats, gloves, and goggles. So in here we have the table. As you can see in the table, we have control measures for specific hazards in the lab. So for the chemical exposure, the control measures is use PPE like gloves, goggles, and respirators, and then you can handle chemicals in a fume hood and use spill contaminant trays. The type of control is PPE and engineering. And the next one, we have spillage during the jar test. So for the control measures, we can see in here you can doing like provide spill kits and contaminant trays, and then train the personnel on proper liquid handling techniques. And for the type of control, it's from engineering and administrative. The next one is equipment measures. So for the control measures, it's to conduct the regular maintenance and calibration, and then you can provide operational training and enforce for the SOPs. And it's administrative is the types of control for the equipment measures. And then postural strain. So for the postural strain, the control measures is ergonomic. Use ergonomic furniture like adjustable stools or mats, and then schedule the breaks and rotate the tasks to prevent the fatigue. So the type of control is the administrative and engineering, of course. And the last one, we have waste management hazards. So in here, for the waste management hazards, for the control measures, you can do like label the waste containers clearly, and then train the personnel or proper waste in disposal practices, and then you can conduct waste audits. For the type of control, it's administrative type of control. So periodically, control mechanisms should be reviewed and enhanced to accommodate emerging risks or technological advancements. A safe working environment must be maintained through staff feedback, audits, and then monitoring. And then the next one is the results from laboratory research. For the SVI performance and jar test, we have coagulation effectiveness. For the jar test, was used to stabilize the ideal coagulant dosage and mixing rates at an alum concentration of 20 over liter, and then the results revealed clear water layers with an average settleability time of 10 minutes. And then for the sludge volume index or SVI, we got the SVI analysis suggested appropriate settling the characteristic by showing the effective sludge compactness in an SVI range of 50 until 120 milliliter over gram. So for the risk and safety results, we have several risk and safety results, like after controls were put in place, no reports of chemicals exposure accidents were made. And then by using trays and handling equipment properly, we can spill the incidences decreased by 70%. And the last one, with modified observation techniques, staff members reported increased ergonomic comfort. So the HIRADC framework guaranteed continuous research quality while successfully reducing the laboratory risk. Safety laboratory operations were immediately impacted by proactive danger detection and control strategies. Certain risks, including chronic ergonomic strain, necessitate ongoing the observed uh, and further the modifications, and the environmental chemistry laboratories use of the HIRADC in coagulation and sludge settleability studies greatly improved safety and decreased the operating hazard. It is advised that HIRADC training be standardized for use in all laboratory activities and integrated into the curriculum. So actually, the next one we have the risk control plan for the jar test, and then for the SVI itself. And as you can see in the table, uh, it's categorized for the hazard scenario, exciting control, the value of the risk, the elimination, substitution, engineering control, and then the administrative control itself. Same as well as for the SVI, and as you and conversely, SVI-related hazards concentrate on the dangers that arise from handling sludge. Training on safe handling and the use of splash barriers are necessary because spills or splashes during sludge movement might result in skin contact or inhaling of hazardous materials. Sludge management procedures should be automated, sealed transfer systems should be installed, and local ventilation systems should be installed. And another risk associated with sludge observation is direct skin contact or aerosol inhalation. Although exciting measures, including mask or protective clothes, are crucial, but it is advised to reduce exposure by eliminating the manual observation by employing fume hoods or closed observation chambers, and enforcing time limitations for observations and substituting the real-time equipment for manual monitoring are essential because prolonged observation periods can raise the hazard from exposure to dangerous compounds in sludge. And the table also discusses the risks associated with using the glass containers to transfer sludge because they can shatter and injure the people. For safer handling, it is advised to move to non-glass or shatterproof containers. Maintaining orderly workspaces and implementing routine housekeeping inspections are advocated since cluttered work environments increase the danger of inoculation, unintentional spills, or falls. So that's all from me. You can see in the next slide for the conclusion. Thank you.
Hello, my name is Laras Sati, so I'm going to summarize what my friend said before. Significant improvements in laboratory safety resulted from the application of these control techniques. For instance, chemical spill incidents decreased by 70% following the implementation of spill containment system and appropriate training on liquid handling. Additionally, ergonomic conditions were enhanced, which made it more comfortable for employees to perform extended activities. Additionally, no incidents of chemical exposure were reported during the study, demonstrating the effectiveness of the safety procedures. According to the study findings, laboratory safety can be greatly improved by employing HIRADC for proactive risk management. To guarantee that all staff members are prepared to handle risk efficiently, it is advised that HIRADC training be standardized and incorporated into laboratory curriculum. The report also recommends that the safety procedures be evaluated and revised on a regular basis to account for new technology or developing dangers. The study guarantees the correctness and dependability of the research findings in addition to the safety of the personnel and students by establishing a secure working environment. The study highlights the significance of strict risk management procedures in learning and research settings and offers other academic institutions a useful manual for raising laboratory safety standards. I think that's all from us. Thank you for watching and thank you very much.